Another application involving exponential functions comes from Newton's law of cooling. So here's what the rule states. The rate of change in the temperature of an object is proportional to the difference between the object's temperature and the surrounding temperature. So that gives us the differential equation that we see down here. So if an object cools from y degrees in a room kept at a constant temperature of r degrees, then we have the derivative is equal to k times y minus r. And by separation of variables, we can get to this solution equation that you see down here. We're not going to prove that that is in fact the equation, but we could do the separation of variables and eventually get to this general solution. So how does this work in a specific situation? So here we go, problem number 8. A room is kept at a constant temperature of 70 degrees. So that's the R. So R degrees is equal to 70 degrees. Okay. If an object cools from 200 degrees to 180 degrees in 15 minutes, how much longer will it take for the object to cool down to 160 degrees? Okay, so here's what we have. We have a starting temperature of 200. So we have when time is 0, the object is 200 degrees. And then 15 minutes later, when time is 15 minutes, we're down to 180 degrees. So in that 15 minutes, the temperature dropped 20 degrees. The question is, how long will it take? What's the time to get down to 160 degrees? Okay, so we need to find t. So what we're going to start with is our general solution, which is the y equals ce to the kt plus r. But we know what r is. R is 70 degrees. Okay, so now I'm going to plug in my initial condition. I'm going to plug in this point first. Okay, so I'm going to have 200 equals ce to the 0t is just, or 0k I should say, is 0 plus 70. Take away the 70, I get 130 equals c because e to the 0 is just 1. So now I have a slightly more specific equation to work with. I now have y equals 130 e to the kt plus 70. Now, because there were two unknown constants, k and c, we had to have two initial conditions, and that's where the second initial condition is going to come in. So we're going to take a look at this initial condition down, plug that in. So then I'm going to have 180 degrees equals 130. E to the k times t is now 15 plus 70. Take away that 70 to get to 110 equals 130 e to the 15k. Divide out the 130, and we're going to end up with 11 over 13 here equals e to the 15k. We're going to take the natural log of both sides, so we're going to get the natural log of 11 over 13 is equal to 15k. So then k is equal to natural log of 11 over 13 divided by 15, or 1/15 of that natural log. Okay, now where do we go? So we have our particular solution now. We have y is equal to 130 e to the k. I'm just going to write k because it's a cumbersome number to write, but remember, we've well defined it so we can write k there, and then I'll plug it in at the very end. And I want to know this down here. I want to figure out when do I get to a temperature of 160. So I'm going to do 160 equals 130 e to the kt plus 70. Take away that 70, you get 90 equals 130 e to the kt. All right, divide out the 130 and you're going to get 9 over 13 equals e to the kt. We're going to take the natural log of both sides. So we're going to have the natural log of 9 over 13. It's a 9. There we go. Equals kt. So t equals the natural log of 9 over 13 divided by the k. So now I'm going to fill in what that k was equal to. So I'm going to write it as 1 over 15 natural log of 11 over 13. And now I go to a calculator to figure out an approximation for this. And it comes out to approximately 33 minutes. Yes, I know I should carry more decimals than that, but we're going to go there. Okay. We're going to just go to the whole number here, right? Now, the question is, have I answered the question? It says, how much longer will it take for the object to cool to 160? So it's going to take 33 minutes to get down to that temperature, but 15 minutes has already gone by. So we're actually going to modify this, and we're going to say it will take, cram it over here, about 18 minutes longer. Now, where did I get 18 from? Okay. 15 minutes have already gone by to get down to 180. So to go from 180 to 160, it's going to take an additional 18 minutes because 15 and 18 gets me to 33. All right. So it's going to take an additional 18 minutes longer to get down to that 160 degrees. So the closer that the temperature gets to the room temperature, the longer it's going to take to actually get down to room temperature because there's less of a temperature change in place. All right. So it's going to more gradually change temperature as it gets closer and closer to room temp. All right, that's it. Let me know if you have any questions.